Now, by way of introduction to our next speaker, I was at another conference earlier this week, and three separate people, and this has not happened to me, three separate people said to me, "Have I seen you before? I'm sure I know you." And someone told me a great response, and was, you know, if ever this happens to you, a bit of free advice, just say, "Oh, it's TV, I've seen you on TV." It works. They go, "Really? Yeah, TV." It's actually not true for me. I don't think you've seen me on TV unless you've seen me on the web. But that is not the case for our next speaker, Mark Pesce, who's a futurist and technologist. You have quite likely seen him on the ABC's New Inventors. He has certainly made a name for himself internationally in terms of his ability to articulate not just what technology does, but where it's going. The title of his talk is Through a Futurist Gaze, Insurance 2020. Please welcome to the stage, Mark Pesce.
Good morning, everybody. Now, I know we've had a good time at this conference talking about how wonderful the future is going to be. I need to spend some time disabusing you of that vision. We're going to start in the year 2020. You take your smartphone out of your pocket at home. There is nothing unusual in this because in the year 2020, 80% of all adults on planet Earth are now using a smartphone. You open up a smartphone and you tap on an app. A map of your neighborhood appears. You see these little icons of black cars floating nearby. You tap the order button and one of the icons slowly begins to move to your location. And you gather your packages, which are very delicate. By the time you've made it outside, there's a cute little vehicle. It's pulled up on the curb, it's opened the door, it's popped open the boot in the front. It waits for you to load up your packages and get in, and when you get in, the door closes, it swings shut behind you, you fasten your safety belt, the car takes off, and this is when you realize there's no one behind the wheel. Now, you barely even notice this. You have been engaging these driverless taxi cabs, or auto cabs, as they're now called, for about 18 months. Your feelings about being ferried around by a computer have gone from this weird sense of future shock the first time it happened, to basically you just ignore it. It's completely normal. It works. And really, that's all you care about. Now, you start driving, it is a stormy day, it is a very windy day. You know what those days can be like in Sydney with those very big gusts. The gusts are hitting the car from all sides. It's no big deal because the computer is focused. It is not trying to juggle text messages and the radio station and the defroster and the road conditions all at once. The computer is a better driver than any human being could ever be. And because of that, these little auto cabs have started to take over in Sydney. There aren't even that many manual taxi cabs anymore. They're being replaced by auto cabs. And in the city's trendier neighborhoods, people have given up owning their cars for pool ownership of these auto cabs. It's the hot new trend. Now, the wind is really starting to come up now. It's starting to gust to almost 100 clicks. That's within the operating tolerances of the auto cab, but only just barely. Now, one of the great things about auto cabs is how quickly they can respond to changes on the road, because they're always observant. They're always going to adapt to something that's happening. But of course, nothing is perfect. Not every situation can be anticipated. In the oncoming lanes of traffic, a large truck suddenly swerves toward the center lane. On the outside of that truck is another auto cab. That auto cab adapts to the truck by straddling the lanes of traffic. And you're in the opposite lane, and you're barreling down on that other auto cab. There's no good answer here. Someone is probably going to get smashed up, someone might get hurt. In the best case scenario, everyone walks away unscathed, the auto cabs are a total loss. That's the best case. Right now, of course, you're wedged between a truck and an auto cab in the oncoming lane, and it doesn't look like the best case is the most likely one. Now, a human driver would yank the steering wheel, one way or another. They would pump the brakes. They would do something. They would do anything to avoid a crash, even if that made the situation worse. How do computers react in that situation? They obviously will want to avoid injuring their passengers or themselves. But when it's a them or us situation, who takes priority? Why do they take priority? And who programmed that decision? Welcome to the world of the 21st century. This is a world that has enough intelligence embedded in it to make decisions. And it's a world that has enough intelligence in it to pose real questions about ethics, about responsibility, and about liability. We're only just getting started here. Now, luckily, everyone emerges from the crash shaken and traumatized, but basically unhurt. That said, those very expensive parcels that you loaded in the front boot, they got destroyed. So you now need to recover $10,000 in lost value from someone. But who? Do you go to the auto cab company? How about the auto cab company that owns the auto cab that you just smashed into because it straddled the lane? Or maybe the manufacturer of that auto cab? Where do you even start here? Well, first step is you retain counsel. And your counsel is actually stumped by this too. This is a new area of law, what they call robot torts. The precedents aren't very well defined. Where they exist, they're frequently contradictory. Too much has happened too quickly for the law to produce a stable or regular response to this accident. So your solicitor very wisely retains a legal expert who has specialized knowledge in this area. That expert, known as Powered by Ross, is actually a highly specialized artificial intelligence, an AI, that has the capacity to read through, understand, and prioritize the proceedings of every case that touches on these sorts of issues. Now, because Powered by Ross has the capacity to digest thousands of case law examples, it can do far more than a human being can. It serves the same role as an army of legal researchers. It synthesizes all of the relevant case law, hands that to your lawyer, and then she decides who she's going to file the lawsuits against and the arguments she's going to make in those lawsuits. But there's a problem. Powered by Ross is still quite new, and the area of law that you've asked it to research is also quite new. Powered by Ross works really well when there are many years of case law to refer to. An area of case law that's only a few years old produces results that are unexpected. In other words, wrong. And because your lawyer relied on Powered by Ross, your complaints are dismissed by the court. Now, you're left wondering whether you shouldn't be teaming up with your lawyer to sue Powered by Ross for legal malpractice. Can you sue an artificial intelligence for making a bad decision? It's the same question we asked in the auto cab smash. And it's a question we will be asking a lot. Now, the words artificial intelligence often evoke a very strong reaction. We remember the cool, methodical psychopathy of HAL 9000, the tireless attacks of the Terminator. More recently, we found humans trapped in the hallucinatory embrace of the Matrix. Cinema has taught us to fear any intelligence that rivals our own. But in the real world, in this world, 4 years ago, IBM took the wraps off a project they'd been working on for a decade known as Watson, named for the founder of IBM, T.J. Watson. IBM announced that Watson had the capacity to understand natural language. That means it could read documents and interpret them. It could digest them, add those documents to its own understanding. So anything that it could find online, Watson could read and, in a sense, understand. Now, to back those claims up, because that kind of sounds like something out of science fiction, IBM decided they were going to prove it. They arranged for a tournament of Jeopardy! Now, that's a hugely popular American game show in which you get the answer and have to formulate the question. And that's actually hard for people to do. It's even harder for computers to do. And IBM said, okay, we're going to make Watson play Jeopardy! And we're going to get the two best human Jeopardy! Players who have never been defeated by another human being to play Watson, and we're going to broadcast this live so that if we fail, the entire world will know. And in fact, what happened was that Watson demolished its human competitors. And as soon as that happened, IBM said, okay, we've done this, now we're going to send Watson to medical school. And IBM has had, for many years, very deep links into healthcare. One of the organizations they have links with is the Memorial Sloan Kettering Cancer Center, probably the best place to go if you need treatment for cancer. And tantalized, the staff there began teaching Watson everything they knew. They gave it access to hundreds of thousands of patient cases that it was able to analyze and to learn from. And now, Watson might be the best trained oncologist on planet Earth. Now, that's not something that IBM will say out loud. That's not something you'll find an oncologist saying out loud, because that's not Watson's role. IBM is now running around the world selling Watson as a service to doctors so that it can be consulting on patient cases. So they gain access to Watson via subscription. And of course, through Watson, they gain access to Memorial Sloan Kettering's centers of knowledge. Now, in some very interesting ways, Watson's capacities far surpass any other doctor, because Watson is fully aware of the tens of thousands of clinical trials that are happening all around the world at any moment, and Watson can recommend those trials as soon as conventional therapies are seen to fail. And no matter how conscientious any doctor is, no doctor can be aware of all the trials that are happening anywhere on Earth all at once. And of course, another capacity is because it's artificial, you can copy and clone Watson as many times as you want. You can only see a few hundred patients at Memorial Sloan Kettering Cancer Center. But Watson means that that depth of knowledge and experience can be delivered to any doctor anywhere in the world. But of course, it also means that any mistakes that Watson makes, any errors in its programming, or gaps in its understanding, they get replicated too. Artificial intelligences like Watson are amazing. We're going to come to rely on them. They're also a crutch, because where we use them, we become dependent on them, and it becomes very difficult for us to see the holes in their learning. So, would it be the doctor that's guilty of malpractice here? Or is it Watson as the quiet voice that's whispering in the doctor's ear and advising the doctor? Where does the liability lie? Powered by Ross, that legal eagle that failed so spectacularly, it's also built on top of Watson. So would we sue IBM? Would we sue the programmers, the vendors, everyone? How are those companies indemnified and insured against decisions that artificial intelligence is making thousands of times faster than any human being can assess? We may have one answer this year. In a decade's time, when artificial intelligences have become pervasive, when they've become essentially unavoidable, we'll probably have a different one. Of course, we could just decide that we'd rather not deal with any fancy auto cabs and any artificial intelligences. We'll drive ourselves around, thank you very much. Our lawyers will hire human paralegals to do their research, and we will visit real human doctors. But then again, that doesn't mean that everyone else on the road or in the legal system will agree with our choices. Nor does it mean that we'll have no problems with human doctors. For example, one morning you wake up and find yourself covered in spots. That happened to me a few years ago. That was the first day just before I was diagnosed with chickenpox, which I don't recommend as an adult. So what do you do in this situation? Well, you feel crook. Maybe not so crook, you head to the emergency room, and it's a Sunday, so your GP's offices are closed. So what do? Well, you realize that there's an app for that. And you point your smartphone camera at your spots, and you snap a photo, and you upload it using the app. And when it's uploaded, the company behind the app transmits the photo anonymously to a qualified dermatologist who gets paid $10 to spend 2 minutes looking at the photo and writing up a brief report, which is then sent back to you. And you pay $50 for this, most of which is being covered by medical insurance. But there's a problem. Your photo gets uploaded correctly, but it gets mixed up with another photo, someone else's rash. You get the word not to worry when actually you've come down with a highly contagious illness that's going to keep you in bed for a month. So who's to blame there? Is it the doctor who made the diagnosis? Is it the company that wrote the app? Is it the Pakistani contractor who wrote the back-end software that sent the wrong photo to the doctor? Is it you for trusting telemedicine? Now, this app is already available. It's known as FirstDerm, and I actually had the opportunity to talk to the founders of this company earlier this month, and I asked them specifically, because I was writing this talk at the time, what do you have to do for insurance here? And they said they actually had to get a special policy written to cover something they identified as telehealth. And that covers both doctors and patients using their service. They see that as a stopgap because telehealth isn't a normal part of a doctor's malpractice insurance. It's not a normal part of our private medical insurance because in 2015, this is still quite rare. But in 2020, when 80% of adults have a smartphone and everyone is doing everything via an app, telehealth is going to move from rare to common, and most doctors and most patients will require some form of telehealth insurance. Medicine is by far the most important, but definitely not the only area where connectivity is going to affect how we assess risk. As the cost to connect things drops, more and more of the world is becoming connected. We are entering the era of the Internet of Things, where nearly everything is going to be connected in a global network of devices. What this comes down to is that if something uses electricity, it's going to be connected. The current prediction is that in 2020, there will be 33 billion connected devices. That's 5 devices for every person on the planet. And that means we are entering a time of unprecedented risks. Something as simple as a children's toy connected becomes a source of risk. Tech publication The Register, which I read a column for, last week reported on the dangers of the new Hello Barbie doll. Toy maker Mattel, which manufactures Hello Barbie, has equipped it with a small computer and a speaker and a microphone and Wi-Fi, so it can listen to the things that children say and it can respond to them. When you press Hello Barbie's belt buckle, what happens is it records what the child says, it uploads that recording to computers somewhere in the cloud, it analyzes what the child said, and then prompts Hello Barbie to emit one of a number of predefined recordings. Turns out that Mattel is offering a service where it can email parents the questions that are being asked to Hello Barbie by the kids. Something that's simultaneously helpful and really creepy. Children do not expect their toys to spy on them from mom and dad, and parents would probably be shocked at what the kids say when they're away from their gaze. That is not the worst of it, however. Toy Talk, which is the company that actually designs Hello Barbie for Mattel, is going to store all of the conversations those kids are having with Hello Barbie, very quickly gaining a very private and very unfiltered window into millions of homes around the world. So even if Toy Talk takes a solemn vow never to misuse any of those recordings, the same could not be promised if a hacker broke in and stole them. And you have to imagine that Toy Talk is going to be sitting on the best source of blackmail that has ever existed. It's going to be an irresistible lure to some bad actors. And so, unless Toy Talk is capable of protecting that data more securely than any bank, which is something that seems extremely unlikely, those recordings will eventually end up in the wrong hands. There is no real safety in the connected era. There is only best practice. And even best practices will eventually run afoul of some disruptive innovation that makes all of your existing security strategies irrelevant. The more connected you are, the more attacks you invite. Okay, so let's have a think about another hypothetical appliance, the connected oven. You may already know where this is going, but indulge me. The connected oven pairs with a smartphone-based recipe app so that you get the settings right for the perfect bake every single time. And of course, that sounds really delightful. But when you go away for a fortnight's holiday, someone hacks into your oven, turns the gas on, waits 36 hours, lights the pilot, and then you have a problem. That's a much worse problem if you happen to be at home at the time because your oven could gas you in your sleep. Ladies and gentlemen, welcome to the oh my God, what have we done era of computing. 33 billion devices means 33 billion risks. Each of them has their own exploits, their own weaknesses, and their own vulnerabilities. And there is no way to stay on top of that. I'm not even sure if there's any way we can comfortably decide that we can ensure any of that. If just one device inside of a house can go berserk and infect and subvert every other connected device in the house, how can we let anyone bring anything into their homes unless it's been fully vetted? And as any programmer is going to tell you, it's actually not possible to fully vet something. Every connected device brings with it risks that can never be fully measured or analyzed or neutralized. The connected world brings with it incredible capacities, but those capacities come hand in hand with undeniable risks. And there's no escaping those risks. We can work to mitigate them, we can establish standards and testing for weaknesses, but the essential nature of connectivity is that it multiplies unpredictability. We already see major companies like Sony suffering massive economic damage because someone used connectivity to attack them. Now, I don't know if Sony was insured against the hundreds of millions of dollars in losses that they suffered because of their own security lapses. But you have to imagine that insurers are now analyzing those attacks and sharpening their pencils and drafting new policies to protect businessmen against the kinds of losses that they're going to suffer as the price of being connected. All of the examples I presented thus far are not problems to be solved. They're dilemmas because they arise from the essential way things are. Dilemmas can only be endured. They can also be insured, but they can only be endured. People are always going to make mistakes, systems will always be imperfect, and there will always be bad actors out there. Our civilization of connectivity and artificial intelligence amplifies the capacity for errors to become catastrophic. We can do a lot more than our grandparents could, but we're going to pay a price for that capability. So the insurance industry has to scope the new risks present in a connected and intelligent world. That world is going to need a lot of help de-risking its activities. At the same time, the business model for insurance is going to change radically, and that presents an existential threat to the insurance business as usual. So let's talk about that. The world of finance is right now being hit with the wave of innovation that is greater than anything that has ever come before. Much of that is being driven by the smartphone. A single iPhone 6 has as much computing capacity as the entire year's run of IBM mainframes 50 years ago. And Apple is making 200 million of those this year. And that's going to lead to the rapid adoption of digital currencies, things like Bitcoin, and systems that use algorithms to make redundant the infrastructure of finance and banking. You no longer need clearinghouses. You no longer need currency exchanges. You no longer need credit networks. Banking is being transformed by the advent of these digital currencies. Financial services are coming to live more on smartphones than they are in smart steel and glass skyscrapers. And that's just the beginning of where this is going. Now, insurance is another class of financial instrument. It is not immune from these changes. The one thing that you need to leave here understanding today, if you take nothing else from my talk, remember this. The barrier to creating financial instruments is dropping precipitously. People are going to be able to make an app that has most of the functionality of a bank. Once they can do it for a bank, they will also do it for an insurer. And so you're going to see a generation of smartphone apps that are going to start undermining your fundamental business models. Those apps are going to provide insurance at a fraction of the existing cost because most of the expensive, slow, human bits will be engineered out by clever algorithms and artificial intelligence. And those apps are going to be competing against one another for business. Those apps will improve in quality, and they're simultaneously going to be lowering costs for their users. The insurance industry, as it exists today, might not even get a look in. And this is already happening. It is already happening fast. Within 5 years, the major players will have launched. Within 10 years, they will be coming to dominate the industry. Within 20 years, they will be the industry. So your best chances lie in making broad investments in any technology startups that are seeking to disrupt your business models. As those models succeed, as they scale into billion-dollar businesses, you will have a seat at the table and a share of the profits. If you have the risk appetite, I would recommend that you partner with one of the fintech accelerators that are popping up now in Sydney and in Melbourne, or launch one of your own. You can build the engines of your own disruption. You can own majority stakes in them if you start today. It can be done. Peter Drucker once said that the best way to predict the future is to create it. You won't be able to control all the risks thrown up by the future, but you can put yourself in the best position to convert those risks into opportunities. Thank you.
some questions. Who's first? Your hand up.
And just so you know, the URL on there will take you to the talk. It's already up on my
I
blog.
saw you here first in the middle. This gentleman here.
Hi, my name's Mark Kelly for Cybernetic. We actually look after, we offer a service to provide some cyber security. My question comes, I stayed in the Hilton last night, and I haven't been staying in hotels for a little while, but when I opened the fridge, it said, there's a warning on the front, you've probably seen this as well, this fridge is connected to the internet, and everything inside was ready. Trying to think about how someone like a disruptor like Airbnb would say, well, are they going to have everyone buy their own little fridge that's connected to the internet, etc., and things like that. And on one hand, you possibly haven't answered the question, or no one's asked it yet. It's all very well and good to talk about driverless cars, but someone somewhere's got to set up $1 billion network to create the cars first. And we've already got cheaper cars with cheaper people driving them. So how does that balance, is my question.
There seems to be, I agree with you, I think with any of this there needs to be strong economic cases made for them. I believe that the marginal cost of adding a robot driver to a car is substantially cheaper than actually having a human driving the car. And I believe that that will end up being a cost driver in that situation, because Moore's law is essentially indicating that the cost of computing becomes twice as cheap every 18 to 24 months. The limiting factor with robot cars has often been the sensor technology they're using, both the cameras, which have now gotten a lot cheaper, and the radars that they use around them. Whether we're going to have fully robot cars as we understand them in 2020 that can take any street anywhere, or whether we're just going to have cars that are very good within CBDs, which is what it's looking like now, is hard to say. But what you can say is that it's a thin end of the wedge, that those cars will continuously become more capable. They will, on average, be far safer than human-driven cars because they are less subject to the distractions that affect human drivers. And so people will tend to maybe want to put their kids in a robot school bus or in a robot taxi because they're thinking they're going to be safer. And so that will be another factor. As an insurer, you may give someone a much lower premium if they use a robot car versus if they use a human driver car, because you actually understand those risks better.
There's a question at the back here.
Hi, it's Brett Dees from Zurich. Algorithmic trading in financial markets has been blamed for destabilising things. So how do you see that playing out in the world of artificial intelligence?
And I think that's a really good example of how connectivity increases unpredictability. And I think what you're going to see is that situations like that will become endemic to our civilization as a whole. And that one of the features of the mid-21st century will be weird crashes. You know, already your smartphone is like, I don't know what it's doing, it's acting weird today, I've got to turn it off and turn it back on again, because the systems and software on it have become so profoundly linked, but also so big that it's very hard to know when a weird bug is going to show up. So in essence, the future will be riddled with weird bugs, some of which will be expensive, such as trading bugs, some of which will be dangerous, such as if my oven decides it's going to fill my house with gas, or things like that. But this is essentially the future we've consigned ourselves to, because we're adding intelligence and connectivity to everything.
So stock market crashes, hit reboot. Right? Is that the idea?
Well, of course, and of course that's what often what happens is they'll go to the audit trail and they'll roll it back X number of hours and say, okay, all the trades before this position were valid and all the trades after that were invalid. So it's essentially what they're doing.
Just here. Thank you.
So I definitely, very scary in many ways, but on the flip side, if things may become more predictable, because let's say there is a bug, now you can identify that there's a bug and fix all those cars, or set a patch, what we do today, So whereas in humans, somebody has an accident, you can't apply that, even if you try, recalls, and it's much more complicated to fix things that once you've identified a factor. So do you see that in some ways making assessing risk and fixing risks easier in the future, or maybe there's...
I do. I think you see exactly the same thing with airplanes, because airplanes get debugged from having crashes, and they will fix a body or they'll fix the software in an airplane, and so airplanes become progressively more safe as time goes on because of this. So I think at one level, the basic functionality, yes. But then because these things are in the real world and they're always encountering very different situations in interacting with all these other systems, you won't have, any programmer is not going to be able to have tested every possible situation that the software that's running a car could be used in. And so you're going to be constantly finding those new corners. Yes, over the course of 50 years, this probably means that you get much better cars. Over the course of the first 20 years, they're probably safer than what we think of as human-driven cars today, but they're probably not going to be as safe as they are 50 years from now.
It is time for morning tea. We'll squeeze in one quick question here.
Charlie Camphor from Claymology. It's very interesting to see, and it's to talk about connectivity and technology driving productivity and all of those things, making things faster, cheaper. Do you see a ceiling in the future? Like how far can it go, really? I mean, you know, it's a difficult answer, I guess, but is there a ceiling?
That's a really good question, and the answer is that there are certain friction points that always exist. Like, there are certain times where you're going to need a human being to assess something or to look at a claim or all of these things. And so there are systems that are not as perfectly friction-free. You're not going to have an economy that's run by robots for robots, which is, I think some people actually do believe this. But there are actual friction points. And the businesses of the 21st century figure out how to make those friction points, which are barriers to entry in the market, make those their points of business excellence. It's how do you actually deal with the frictions you can't get rid of that makes a business excel in the 21st century.
Would you please thank Mark Pesce? We are going to break. Our coffee sponsor today is Touchpoint CX. Our juice sponsors are Merchant Suite and Premier Technologies. The Wi-Fi sponsor is AvPoint. The cocktail sponsor was Interactive Intelligence. Can I remind you, please do visit the exhibitors and sponsors out there, and we will see you back here at 11:05. See you back here at 11:05. Thank you very much.